So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which we are going to talk about another beastie looking infinite series. And what's that? Let me just show you right away. So, here it is. So basically we are gonna talk about the proof of this beastie looking infinite series of the cotangent function itself. You know what the crazy part is? This is going to be very easy proof, believe me, because we are gonna do nothing rather than just taking natural logarithm both sides and just taking derivative. That's it. We are good to go with this infinite series. But what we need is the most amazing thing, because what we are needed here to take the natural logarithm of the that equation, or to take the derivative of. So what's the equation is? The equation, or the generalization of the thing that we are studying so far. Like if we talk about if of my some last videos, like 2 3 videos, so you might have noticing, like I'm just bringing videos on the proof of this thing: sine theta equals theta times the product as n goes from 1 to infinity of 1 minus theta squared over n squared pi squared. So this is the thing that we are gonna deal with today, and we are gonna take the natural logarithm or the derivative. Well, we'll do it in step by step, so don't worry about that. But you know what, why I'm just following this series, and why did I just proposed you 3 videos on this one also, like the proof of this one, the using the Gaussian representation of the gamma function, the Weierstrass infinite product of the gamma function, and even the most fundamental, this one, sine a plus b, or maybe sine double angle formula, as you might have seen the most last video of mine. We just began our journey with this formula only to prove this down. So that's really amazing, and I would recommend you to just watch that video, because you are gonna get to know a lot of things. Okay, but for now let's talk about this, and that is why I don't want to jump over this without the proof of this one. So that is why I was just bringing proofs on this one to make you clear about everything. To you just have to know what is this, right? And now let's just begin the proof of this crazy thing from here, right? So let's just prove this down. So basically, as I told you, our roadmap is gonna be something like this: taking natural logarithm, then take the derivative, and then some rearrangement. That's it. We are gonna good to go with our this infinite series for cotangent. Let's do that right away. Or maybe I should consider writing is that theta equals pi z. Let's just consider writing it as, so basically we are having sine of pi z. Oh, I think, yeah, pi z equals pi z times the product as n goes from 1 to infinity of 1 minus, well, if we plug here pi squared z squared, so this pi squared cancels out with this one, and we would be left with z squared over pi squared only, right? I'm sorry, z squared over n squared. So let's just take natural logarithm of this equation, right? Let's just take natural logarithm both sides. So taking natural logarithm both sides of this equation, right? So that's what's that gonna give us. Basically this product is gonna change to an infinite series. That is why we are just taking that in order to get that series, right? But it's amazing to notice here, because if I wouldn't have the idea of logarithm, I would not be able to convert this infinite product into this infinite sum. How crazy is that, guys? Okay, and yeah, it's pretty fine. Okay, let's just take the natural logarithm. So ln sine of pi z equals ln of this big chunk of things. Wait a second, yeah, it's pretty fine. Okay, 1 minus z squared over n squared. Okay, now we are having this term being multiplied to this term, and this term is being multiplied with each other. So basically we would be having 3 natural logarithms. And you know what, oh wait a second, let me just go by step, don't worry. sine of pi z, and this becomes ln of pi plus ln of z plus ln of this infinite product. And you know what, if you are having ln of an infinite product, so that's gonna give us the infinite sum of ln of that argument which you are having with the product, right? So basically our ln sine of pi z is gonna be something like this: ln of pi plus ln of z. Wait a second, I'm just messing up with z, I think. Yeah, it's pretty fine. Okay, so basically this is gonna be an infinite sum here from n equals 1 to infinity of this ln and of this argument, as I just told you here. So yeah, this is what we are having, and now we are just going to take the derivative of with respect to z both sides, taking derivative with respect to z both sides. So what's that gonna give us? So basically I'm talking about d over dz of ln of sine of pi z, right? And d over dz of this whole big chunk of things. Yeah, it's pretty fine. And this sum as n goes from 1 to infinity of ln of 1 minus z squared over n squared. Okay, so now we can just consider taking the derivative of this right hand side. So we can say that it's 1 over sine of pi z, and with the chain rule the derivative of sine of pi z is cosine of pi z, and the derivative of this inside function, that is the argument, is pi. So basically we would be having pi times cosine of pi z over sine of pi z. Fine. Okay, now since we would consider just bringing this derivative in this parenthesis, so we would be having the derivative of this constant term, so that's going to be 0, and the derivative of ln of z is 1 over z, and the derivative of this one, let's talk about this. Okay, so basically we are having 1 over z plus, if we talk about the derivative of this of the argument of the infinite sum, so let's talk about the ln. So it's gonna be 1 minus z squared over n squared, and if we talk about the derivative of this argument, so that's gonna give us minus 2z over n squared, since negative 1 over z square, I'm really sorry, negative 1 over n square is a constant, right? So basically it's being multiplied, so we would not be disturbing it, but we would be taking the derivative of this z square, so that's gonna give us 2z, right? So basically yeah, that's it, we are just left with that. So basically here this cosine of pi z over sine of pi z is gonna be cotangent of pi z along with pi multiplied to this, and we are left with 1 over z plus this sum as n goes from 1 to infinity of, well, we can write this as negative 2z over n squared times 1 minus z squared over n squared. Fine. Okay, and now we're just gonna multiply this into this parenthesis, so we are gonna have pi times cotangent of pi z equals 1 over z times this sum, 1 over z plus the sum as n goes from 1 to infinity of negative 2z over, it's gonna be n squared minus z squared, right? So basically next step is gonna be, let me just multiply this negative inside this this denominator, so that's gonna change the order, and that's gonna give us z squared minus n squared, right? So I hope you are just understanding these kind of steps, because these are elementary and they are not difficult to understand. So pi times cotangent of pi z equals 1 over z plus this sum as n goes from 1 to infinity of, it's 2z over z squared minus n squared. Fine. Okay, and now let's talk about the pi times cotangent of pi z again here, and that's gonna be this sum as n goes from 1 to infinity of, well, you know what, we can just factor this z squared minus n squared as z plus n times z minus n. Okay, and now again pi times cotangent of pi z equals 1 over z plus the sum as n goes from 1 to infinity of, well, you know what, we can write this 2z as z plus n plus z minus n, because eventually this minus n is positive and gonna cancel out. We would be left with z plus z, that is 2z, right? So let's just write that down, something like that. So z plus n plus z minus n over z plus n and z minus n. And now you guys are familiar with this because you are the follower of my channel, so now onwards you can do it by your own, but let me just do it because maybe some of you are new viewers, so let me just make them to our level, make them reach our level. So this is gonna be 1 over z minus n plus 1 over z plus n. And well, since these two terms are being added to each other, so we can just switch up the order and we can write this as pi times cotangent of pi z equals 1 over z plus the sum as n goes from 1 to infinity of 1 over z plus n plus 1 over z minus n. So basically these three equations are equal, and these things are the are what we have began with. Like basically we have to prove these equations actually, and we have done that. Look, so pi times cotangent of pi z equals 1 over z plus this sum as n goes from 1 to infinity of 1 over z plus n or plus 1 over z minus n. So yeah, it's pretty fine, right? And it wasn't tough at all. We just took the natural logarithm both sides and we just took the derivative, that's it. And we just took some we just did some manipulations or rearrangement, that's it. So it's pretty easy and elementary things to understand. When I saw this first time, so I just thought that whoa, it's kind of difficult to prove, but it's not that difficult. The condition that we need to just know about what it is, because we don't need to jump it off. And if you are not familiar with this one, so you can consider just watching my all three videos that I have uploaded on my YouTube channel. And even I have made a playlist on this one, that is Euler's infinite product for sine function, so you can just check that out. And you know what, why I made this video? Because I'm just gonna bring a video in which we are gonna do a beastie thing. Basically we are gonna generalize a crazy thing, and I'm literally just requesting you to come up and watch the next video, because we are gonna use this, and it's not the end. We are gonna use a lot of things. So that video is gonna be quite long, and that is why I would be choosing that video to just record it on my board rather than on like this tablet. So I don't feel mathematics on tablet, I feel it on board actually. So yeah, thank you so much for watching this video, guys. And if you got to learn something from this video, please make sure to like, subscribe and share. And if you have any kind of doubt, so you are free to ask me in comment section. I'll make sure to just reply you as soon as possible. And yeah, I'm just gonna record that video soon, and I'll upload it on YouTube as well. So love you guys, take care, goodbye, and good evening, good morning, good night, good afternoon. It's Truman. So love you guys.